My name's Chris and I repair my own audio equipment, and I also show you how to repair yours. So let's get started. Technics SE9600 power amplifier was discarded as trash. Not happening on my watch. Join me as I take you through the repair, restoration, and the recovery of this beautiful, iconic Technics power amplifier. Not every piece of equipment that I have is in mint condition, but I treat each of them with respect. Each of them can still continue on for decades, even if they'll never look like new pieces of equipment. And I treat all of my equipment the same way. This 9600 received the exact same treatment as if it came brand new out of the box. It doesn't matter to me. I'm going to treat it the same way. I'm going to change out those electrolytic capacitors that need to be changed out after 45 years. I'm going to clean it up a little bit. I'll end up putting it into my system and listening to it. And it just deserves that. And I'm sure that even though this amplifier will never look perfect, it will sound perfect by the time I'm done with it. Before I can listen to it, I've got to get it up on the test bench. But before I get it up on the test bench, I'm going to have to go in there and restore it. And you guys know me, the first thing I'm going to do is take a look at this unit before I power it up. So let's get started. If you haven't already, please subscribe. This 9600's faceplate was a pretty big mess. A lot of dirt on it, a lot of scrapes. Somebody had apparently scraped in their name into the faceplate. Why anybody would do that, I don't know. That's a first for me. The back is a mess. A little bit of corrosion. Just pitted some. I live in Florida, so that could explain it. Same with looking down from the top. It's missing one cover. There's a little bit of surface rust in there. Under the bottom, this shows the unit sitting up on end. I removed the bottom cover. Doesn't look like anybody's been in there. It actually looks pretty clean. But one thing I did find in there was a screw. And this is why I look at these units. You never know what you're going to find. Do you want that screw in there when I power this up? Probably not. And actually, I never did find where that screw came from. I'm really not sure. But one thing I am sure of, I'm glad I got it out of there before I powered it up. Before showing you more of this Technics SE9600 repair and restoration, which included changing out those old electrolytic capacitors, setting up the amplifier, and bench testing it, right now I just wanted to go over the specifications of this amplifier and a couple unique features about it that most amplifiers don't have. First of all, it's 110 watts a channel into 8 ohms. It's 165 into 4 ohms. It's like any of the middle 70s amplifiers. Now this was built from 74 to 1980, this particular amp. I mean, it is just weighs a ton, 50, 60 pounds. You know, whatever you drop it on, it's gonna break, not it. But whatever it hits is going to break it. It just is built in a way that it's still here after all these years. So the unique features with this particular unit, one, it has, I've got the faceplate off. See if I can show you this. I don't know. Well, anyway, you can kind of see the faceplate. It's got right here something called output impedance. And it's a 4-position switch. Click, 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 click. And I looked at it, and what is output impedance? And the four selections are normal, 0.08 ohms. Then the other one is 0.8 ohms. The next one's 2.7 ohms. And the next one's 8 ohms. Well, what that is your damping factor. You can adjust the damping factor to your speakers. Will that affect the sound? Well, I'm going to find out, because I'll give it a try and see if it makes any difference. Usually you have a specification for an amplifier in your owner's manual or in the service manual. It'll say damping factor, minimum, blah, whatever it happens to be. This one you can adjust it. So that's unique to any power amplifier I have anyway. So that's kind of unique. I don't know if it you know what it's going to do for me, but I'm going to have to give it a try and see if it works. If it works, it works. If it don't, it don't. But that was a little bit unusual. Another thing unusual is, I don't know if you guys can see, maybe you can, maybe you can't, right here and right here on these two heat sinks, there's a little yellow dot. And what the heck's this yellow dot? Well, when these heat sinks become 122 degrees Fahrenheit or 50 degrees Celsius for you folks who are somewhere else in the world than the US, this will turn orange. Now, it doesn't shut the amp off, because really those temperatures, frankly, are not very high. They sound pretty high if you were sitting in a room at 122 degrees Fahrenheit, right? But to this thing, it's not going to shut off or anything, but it's just kind of a warning that this is kind of warm now. This is going to feel warm to you. I don't think, it's going to burn you, but, this could get substantially hotter than 122 degrees Fahrenheit. So that was kind of unique. They put a little dot that changes color when the amplifier's temperature increases. So that was pretty interesting. Really, the rest of it is pretty. Oh, another thing too. Unlike my Spec 2, I was going to tell you, my Pioneer Spec 2. I just did a video on that. You guys know that not too long ago, and on the Spec 1. And I was mentioning that the Spec 2 just has one set of speaker outputs. This unit has two sets of speaker outputs. It has an A and a B. Well, actually, I think they call it a main and a remote. But same idea. It does have two sets of speaker hookups in the back. So that's good. And you've got switches here at the front. Again, I'll show you here on, I don't know if you can see it, but there's right here. This is where the buttons would be. There's a main remote. And everything else is pretty conventional. It does have three different meter ranges, sensitivity ranges. Again, this is the front panel. Of course, you'd have buttons there. So if you want to see the meters work a little bit more, you see a little bit more deflection at lower power, you can set it to something more sensitive there. What else on here is anything? It's got level controls, which is nice. That's not unusual for a power amp, but it's got them. There's another thing that's kind of interesting. Here's something called input on and off. All right, input on and off. What that does is disconnect the amplifier's inputs so that you can, supposedly, you can go ahead, let's say you want to hook another preamp up. You don't have to turn it off. Would I do that? Probably not. But that's the idea. You disconnect the inputs here so you don't plug in. Normally you'd never do that. Go ahead and plug something like that into your live power amp or preamp, right? You turn it off, you hook up the cables. But this one, supposedly, you can disconnect it and go ahead and hook it up without damaging anything. Am I going to try that one? Probably not. This is a long video, and I put chapters into this video, time codes. And some of y'all may know how that works, some of you may not. But on a video like this one that's 2+ hours long, You may not want to watch it all. I hope you do. I hope you want to watch it from beginning to end, but you may not want to. So I've put chapters into this video and hopefully given you some descriptions of what those chapters contain. So what you do when you're at the video is hit that show more button and scroll down. And down right at the bottom, you're going to see where I put time codes in. And then there's chapters that correlate to those time codes. You can also use the timeline. There's a timeline here right at the bottom of where the video's running. And you can see along here those same chapters that I just showed you down below. And you can just click on those and go straight to them. You may notice there's a little space in between each of these chapters. There's a little gap. And all you got to do is click on that area. I just wanted to tell you about that, just so you guys know, so you don't have to waste your time looking for something. After looking over the SC9600, I didn't see any reason not to power it up. The only thing I had found earlier was that screw in the bottom of the chassis. So I took a variac and I slowly increased the power to the 9600, and I worked my way all the way up to 120 volts, and I saw no indication that the amplifier was on. The power lamp was not illuminated. The 2 meter assemblies were not illuminated. So my first thought was, well, maybe I've got a power supply problem. I've got some kind of issue, because normally you'll get 1 or 2 of these bulbs burned out, but not usually all of them in a piece of equipment. Now this piece of equipment only has 3 different lighting assemblies. So come to find out, all 3 of them were burned out. So that's one thing you got to keep in mind too from time to time when you power these up. This is an unusual situation, but not unheard of. Actually, the amplifier powered up, but because I had no visual of it being powered up, all those lights were burned out, it had me thinking I had a problem, which I didn't. Even though this is a very rough looking amplifier, I'm going to work on it just as hard as if it were mint out of the box. That's me. I work on the lesser pieces just as hard. And matter of fact, a lot of times these type of units that are in this kind of shape are more rewarding to get going. I'm not going to try to refinish it or make it look perfect, because it'll never be perfect. But there's no reason why this amplifier, I hope, will not operate and be just as reliable as if it were a mint SC9600 coming out of the box. It was not a scratch on it. There's no reason why this amplifier can't work properly for decades to come. So after I determined that the amplifier had actually powered up and just the lamps were burned out, I went ahead and I hooked up a pair of speakers to the 9600 along with a CD player. I just ran the CD outputs right straight into the RCA inputs of the amp and used the level controls on the amp as a volume control, and it worked fine. I mean, it sounded good. The meters were operating even though those bulbs were burnt out, and everything seemed good to proceed. So my next step is to get in there and to figure out what bulbs I need to get the meter assemblies back illuminated along with the power indicator. I'll say it again, always go to HiFiEngine.com and download the service manual for whatever piece of equipment you're working on. The schematic for this SC9600 is contained in the service manual. So the schematic indicates that the meter lamps are 6.3 volt and the power lamp is a 7.5 volt. And now I will have to do some research and run those down. And after doing some research, I found the meter lamps available on eBay. The power lamp, I'm going to replace that with an LED. The meter lamps are a little bit more difficult to replace as they are inside the sealed meters. It's not like there's a little socket on the outside where you can just plug this new bulb into. You have to remove the case, the plastic case around the meter, and then you have to unsolder the old bulb and install the new bulb. Now once you do this, this most likely is going to last another 40 years. They won't have to be replaced very often, but they are a little bit of a pain to replace, right? Because you got to take the unit apart, you got to take the meters apart, you worry about slipping or damaging those meters. So you got to be really careful when you take these meters apart, that you're careful with them. They're very delicate. The power lamp, I used an LED as I indicated, and that was the easiest thing to do, and that was easy to get at and easy to replace. So now we've got both meter lamps working, and we've got the power lamp working. So now the unit looks a little bit better. Looks like it should, right? All lit up. I don't find it very hard to convince most people to change out their burned out bulbs in their vintage audio equipment. Most people would like everything to be illuminated like it was when it was brand new. The hard thing to convince people, at least some people, is to replace the old electrolytic capacitors in vintage equipment. So I do repeat myself somewhat because I think it's very important. The most important component in vintage audio equipment to get replaced are those electrolytic capacitors. That's where the majority of your failures are going to occur. And so again, I'm going to talk about the electrolytic capacitors and why you should change them. And it's not because I think they should be changed. It's because of the manufacturers of electrolytic capacitors say they should be changed. How long do they go? It's hard to say. But most of the manufacturers say 15 to 20 years under normal operating conditions you should expect to get out of a capacitor. I've seen some electrolytic capacitors that literally did blow up. This is a capacitor from an Akai open reel deck that just exploded all over the place. This capacitor is a filter capacitor from a Pioneer integrated amplifier, and it had started to leak, got down inside the chassis, and just really made a mess. That was probably leaking for years. In addition, I had a Sony integrated amplifier where the capacitor blew the artwork right off the board, took out a couple other transistors. So sometimes these capacitors will fail spectacularly. Most of the time you're not going to see failures like that, where it blows off pieces of artwork and there's goop all over your chassis. They're just going to fail slowly, and over time they deteriorate, and you've just got to make your own minds up. Is that important? Is it important to have the best sound quality you can have? In addition to the sound quality, and as I indicated earlier, what I think is more important, reliable. That you can turn this piece of equipment on and know it's going to operate, and it'll probably operate for decades more with some fresh electrolytics in it. As I mentioned, we can't be 100% sure the transistors and diodes and resistors and the rest of the components in it, but you're getting rid of the majority of the problems when you decide to go in there and replace those old electrolytic capacitors. Now I'm going to work through all of the assemblies in this Technics SE9600, including the power supply and the two driver assemblies. I'm also going to reseat all the power transistors and install new mica insulators as well as new thermal compound. After that, I'm going to take it up on the test bench, do idle current and DC offset adjustments, and then run it through its paces and just see what this amplifier can do. Before I start the restoration, I want to share with you a little bit about the history of the Panasonic Corporation, and specifically about their hi-fi history. You don't see a whole lot about Panasonic or Technics, so I want to share a little bit of that with you before I start the restoration. In about 2 minutes, I'm going to show you a video that Panasonic created in 2013 about their company history. It's a really great video to see, but before that, I want to talk about specifically about how they came up with the name Panasonic, and also how they came about to come up with the name of Technics. Those two things were not covered in the video, and so this is about a Technics power amplifier, the SC9600. So I thought it was important to add those two details about how they came up with the Panasonic name and also how they came up with the Technics name. The Panasonic brand was created by Matsushita in 1955 for the United States because the brand that they sold under for the most part in Japan, which was called the national brand, was already taken in the United States by a variety of different companies. So they had to come up with another name for the United States market. And what they came up with was a brand name that was created from two different words. One was pan, meaning universal, and the other word was sonic, meaning sound. So the idea was for pan and sonic to go together, and it would have a meaning of bringing sound that their company would create for the world. So Panasonic was born out of those two words. Now the Technics brand, we got to go even deeper, don't we? We've got Matsushita creating Panasonic, and after the Panasonic brand came the Technics brand, which was used for Panasonic's hi-fi audio systems. And that started in 1965. The first product that had the Technics name was a speaker system. So the question is, the name Technics, how did they come up with Technics? Well, it was coined from the word technology. And the idea was that technology, meaning that it faithfully reproduces the original sounds, and they felt it symbolized Panasonic's commitment to the creation of high quality audio. I would have liked to have been in these rooms when they were coming up with names. I bet they came up with all kinds of combinations. Konosat Matsushita founded Panasonic in Japan in the early 1900s, and the following is a video that was created by Panasonic in 2013 that shows the history of the company.
Konosuke Matsushita, the founder of Panasonic, was born in 1894 in Wakayama, the youngest child of a wealthy farming family. When he was 4, his father lost the family property as a result of ill-fated speculation on the rice exchange. At the age of 9, Konosuke was obliged to leave home to take up an apprenticeship in Osaka. As an apprentice, Konosuke learned the basics of business. Observing streetcars in Osaka, he sensed the arrival of an age of electricity. So at 15, he joined an electric power company. As an extension to his work, he dedicated himself to the improvement of light sockets. When only 23, Konosuke founded a company to manufacture plugs and sockets of his own design, together with his wife and brother-in-law. Panasonic was born. Working late into the night, Konosuke tirelessly strived to improve electrical fittings. He introduced a series of new products offering high quality at low prices and started hiring additional staff. In those days, the composition of molded components was never released to employees. Valuing harmony among his staff, Konosuke revealed the secret for the growth of each individual. After spending half a year day and night, Konosuke finally succeeded in development of an innovative bullet-shaped bicycle lamp. Despite his confidence, it did not sell well, leading to excess inventory. Konosuke then hit upon the idea of offering retailers free samples to demonstrate the lamps. This proved successful, and orders began to come in. Konosuke next designed a square-shaped battery lamp and introduced it with the national brand name for the first time. For the next 80 years, National would attract widespread popularity. Konosuke published various materials to strengthen ties with retailers and employees. These initiatives reflected his philosophy of participative management with collective wisdom. Rapidly growing to 300 employees, the company's management approach began to significantly affect distributors' operations. Konosuke began raising awareness of his company's mission to exist for the benefit of society. He established the basic management objective, explicitly acknowledging corporate social responsibilities. This year also marked the onset of the Great Depression, whose ripple effects halved the company's sales. Konosuke's response: cut production by half, but don't dismiss a single employee. We are going to pay the same wages, but employees need to commit to selling inventory. Encouraged by these words, employees succeeded in eliminating the excess inventory within 2 months. Konosuke visited a temple and was impressed by everyone cheerfully and enthusiastically going about their tasks. He realized that religions are committed to the sacred task of guiding people out of suffering and into happiness. Our business in producing life's necessities is sacred. Konosuke spoke before his employees. The mission of the manufacturer is to banish poverty by producing an abundant supply of goods and making them available at affordable prices. It requires 250 years to fulfill this mission. Our mission is sublime and far-reaching. He then read out the President's declaration. The employees were all struck by the mission's loftiness and the plan's grandeur. This ceremony marked the establishment of the core of Panasonic's management philosophy. Konosuke designated this year as the first year of Meichi, or awareness of the corporate mission. Next, Konosuke established the principles. Then he set up the basic internal rules. No matter how large our company might become in the future, maintain the attitude of being a humble merchant. Think of yourself as being employed in a small shop. Be simple, frugal, and humble as you carry out your work. This discipline has been handed down to all who work for Panasonic today. As the product range was being expanded, Konosuke divided its business by product. This gave birth to the company's unique division system. The aim was to strengthen autonomous management and to develop capable management personnel. Konosuke began to feel strongly that a company is its people. 30-odd years ago, I used to tell young employees, do you know what you should say when a client asks you what we make at our company? You should say that we make people, and beyond that, we also make electrical appliances. The company established its own trading company, and products were exported not only to Asia, but also to Europe. 3 people were sent on an inspection tour to the United States and Europe for 6 months. The company sought to achieve further development by learning from the world. Driven by its unique corporate spirit, Panasonic entered a new phase of rapid growth. World War broke out. As the conflict intensified, the company was obliged to dedicate its facilities to military productions. The day after Japan surrendered, Konosuke announced his desire to restart normal business operations. However, the company's business was severely restricted under the control of the Allied powers, and Panasonic's operations went into the red. The 5-year post-war period was the harshest time in the company's history. In 1950, the Japanese economy began to recover. Konosuke then directed his attention to the West. He made his first trip to the United States. Konosuke became convinced that a technical tie-up with an advanced corporation was essential and established a joint venture company. The Japanese market began to experience a boom of electrical appliances. Rapidly opening new factories, the company expanded its business by leaps and bounds. Ahead of Japanese competitors, the company started overseas operations. The company established its first post-war overseas sales company in the USA. Construction of overseas factories began with the commissioning of a factory in Thailand. The rapid expansion of its overseas business attracted international attention. As the Japanese economy entered a recession, sales companies and distributors were forced into the red. Konosuke called them to a conference. Then, aged 69, Konosuke remained standing on the podium for 13 hours, listening to their complaints. On the third day, Konosuke began apologizing and promised to implement reforms. He took a lead role in reforming the distribution network. I think it is intolerable to stay in a condition without progress for years on end. I think we have to bring out higher management and superior products. I feel keen responsibility for innovations now. An oil crisis struck worldwide. Konosuke expressed his view. In times of recession, while some complain about the bad economy, I simply seek out work that we can attend to. The worse the economy, the greater the need to keep working. Panasonic has advanced as a company because whenever it faces economic adversity, it maintains internal solidarity. Konosuke Matsushita passed away at the age of 94. His activities, rooted in an open mind and a sense of humility, were not limited to corporate management. He also called on the Japanese government to establish a set of ideals. His philosophy of humanity, life, and management, which was rooted in a profound reflection, continues to exert an influence on the world to this day. Successive presidents have continuously passed down the management philosophy. Reawaken the excitement felt at that foundation anniversary ceremony held in 1932. Bring back that sense of passion, that strong will and a philosophy deeply rooted in the desire to contribute to the prosperity of society and human happiness. Starting anew every day, Panasonic's quest for innovation never ends.
The first thing I did before starting the restoration on this SC9600 was to go to HiFiEngine.com and download the service manual. The service manual is going to have all the information you need to adjust, restore, or repair a vintage piece of audio equipment. And HiFiEngine.com is free. You just have to set up an account, and then you can download the manuals, whether you have an SC9600 or any other piece of equipment. So I bring that up often because it's a great resource that's free in today's world. You wouldn't have been able to get this information years ago unless you were a service center. And now it's all out there on the internet. You can sit with your cup of coffee and you can download the manuals you need to keep your vintage equipment going. So HiFiEngine.com is your first stop for anybody who has a vintage piece of stereo equipment that they want to keep running. The service manual will have information on how to check and how to adjust the DC offset as well as the idle current of the amplifier. And in addition, with output meters, it'll also have a procedure on how you can check and adjust the alignment of those. Without the service manual, you wouldn't know how to do this. And with the service manual, I think many of you will find that it's really not very difficult to do. What the service manual also provides are circuit board layouts within, in this case, within the 9600. And these are so helpful when you're restoring or repairing a piece of equipment because it easily identifies each component within that circuit board. This shows the regulated power supply, which they call the power source circuit board, and indicates all the positions of all of the components on the circuit board. What also this shows you is on the transistors, you'll notice there's little charts, and it'll say TR510, TR511, meaning transistor 510, 511, and that corresponds to a transistor on the circuit board. It gives you the collector, base, and emitter voltages that you should expect at those pins. Now, isn't that a great troubleshooting aid? And that's such a help to have something like that here. So even though if you're not exactly sure what's going on, you can get in there and measure at different points. And as long as you see voltages that are similar to what they indicate, that part of the board is probably working all right. But then when you get to a point where those voltages are not correct, you know you're probably getting in the area of the problem. So something like that is invaluable to troubleshooting. Many service manuals, including this one, give you additional information to help you understand the circuitry within the piece of equipment, to help you again to troubleshoot any type of a problem you may have. Some of y'all have asked for me to do a little bit more with explaining exactly how I go about doing the restorations on the equipment I have. So coming up here, you're going to see a lot more details about how I do the restorations. You're going to see how I remove the assemblies, how I get them apart, and also how I pick the parts that I'm going to use for the restorations. In addition, I'm going to show you the soldering techniques, how to get components in and out of the different circuit boards, and just how to do a neat, good job and to have a successful outcome for your restoration. This amplifier is very similar to other pieces of equipment that you may own, whether it's a preamplifier or an amplifier or a receiver. So you can go about using this information to do your restoration on your piece of equipment. It's really not that complicated if you take it a step at a time. I'm going to begin to replace the electrolytic capacitors in the power source circuit board, which again is the power supply of the SC9600, and it sits at the bottom of the chassis. There's just two screws that are holding the power supply assembly to the chassis. I'll loosen up both of those. It appears that the board, I may not have to even remove any tie wraps. I'm not sure at this point. You don't know until you loosen it and you see how it comes out. But it looks like there's just two screws, and it appears that it's loose. You've got the little alignment tabs that you can see coming up through the chassis, and now I'll just rock it a little bit and see what we get. And I'm moving it back and forth. There she goes. Yeah, she came loose quite easily. And there, clears the chassis. Isn't that nice? So it's right out there in the open for us, easy to get at. And obviously a lot of slack in the cables. It's always a good idea when you have any of these circuit boards removed to just take a look at the back of the circuit board and make sure that you don't see anything obvious like cold solder joints or some other issue that you should take care of before you start the restoration. Now I'll write down the electrolytic capacitors that I need, and I have all of these in stock, but you guys that don't have the parts in stock, you'll have to do the same thing. You'd have to take a look at this power supply just like I'm doing, and you write down the values and the voltages of each of those capacitors. You can't really go by the parts list in the service manual. So the only way to be sure is to take a look at what your unit has in it. And that's what you go by. You don't go by anything else. You want to replace the components exactly as they're in your unit. All right, I'm going to start to replace the electrolytic capacitors on the power supply assembly here. This tool here is a godsend. I mean, it really is. It's a Hakko FR301 desoldering tool. And this just makes your life so much easier, so much less risk of damaging any of this artwork. If you ever use it, if you ever do use one of these, you'll never go back not using it. Let me just tell you that. We're going to start with electrolytic capacitors. I've got a couple here that I'm going to use as replacements. These are Nishikon PW series. They're pretty much a standard to put into vintage audio power supplies. This may not be the capacitor that you would use in some areas of this amplifier, but in the power supply, they're really a great capacitor. One thing that about these, they are rated at 105 degrees centigrade. The ones that we'll be taking out are 85 degrees centigrade. So it just gives you that little bit extra. The ones that were in here obviously lasted 45 years. But this just gives you a little bit more of a cushion, and capacitors like this are quite inexpensive. So we're going to go after this capacitor right here. It's underneath here. It's a 47 microfarad 100 volt capacitor. And always take a look too. Like I'm taking a look here now. I don't know if you guys can see this on the video, but make sure you look at how this is orientated as far as polarity. You know, the positive and the negative leads on this electrolytic capacitor, because you've got to put these in correct. And sometimes, most of the time, schematics are 99% right. But it's just so easy to take a look here. I'm looking at this and I see big minuses. So in my mind, as soon as I take this out, I know my replacement capacitor, the negative lead's going to be pointed up, right? So I just take a visual here, and I do them one at a time. I don't take them all out, put them on the table, and then put them all back. I do them one at a time. I'll take this one out, I'll put a new one in, and then I'll proceed to the next one and all the way through the board, because you've got a lot greater risk of making a mistake if you start pulling out a half a dozen of these electrolytic capacitors and then you mix up the 100 microfarad with the 47. It's just much better to just go ahead and do them one at a time. So I'm going to show you how easy this is to take out with a tool like this Hakko FR301. So we take a look, and we usually can kind of get an idea of where the leads are. You get used to this after a period of time, but you just heat this lead a little bit, and you might have been able to hear that sucking the solder right out for me. And now this is a pretty good size one. And you can see on this one, and this is what they do, some of these capacitors. This one here, up at the top, came completely loose. This one still is holding on a little bit. So what we can do is just take our soldering iron, heat that, because they bent these when they installed them. And there we go. We got him loose. So I don't know if you can see those wiggling around or not, but they bent them at 90-degree angles. So these won't come out right now. Oh, it might if you yanked it, but there's no reason to, right? We can just take our pliers and straighten up this lead a little bit. Take our pliers and again, just straighten up this lead a little bit. And you make sure it's loose. The main thing you want to make sure is that these leads are loose from these eyelets. Because if these are still attached and you start yanking on this other side, you'll pull those eyelets right out. And so you just want to take your time, make sure that's nice and loose, and it feels nice and loose. And now I'm just going to pull it from the bottom here, and out she came. Right? Came right out easily. And did a real nice job here removing the solder up on the top side. So we'll take a look here and make sure it's what I think it is, and it is a 47 microfarad 100 volt. And I'll go ahead and get the replacement. And it's interesting, isn't it, whether you guys can see this or not. Here's the replacement here over on this side, this brown one, this Nichicon PW series. And here's the original Panasonic. I can see the little Panasonic symbol here. So this was a Panasonic. Gee, what a shock, right? Seeing it's a Technics amp. I'm sure this one, this amp's full of Panasonic parts, all the ones they could use anyway. And they certainly made electrolytic capacitors back then, and they still do today. And this, I want to tell you again, if you use Panasonic in this, I'm using a Nichicon in this particular spot. But if you want to use a Panasonic capacitor, that's great too. I mean, they make great products. They still make them. You can still get them at Mauser or DigiKey. And if you want to use Panasonic, that's great too. So we go ahead, and you can see the leads are quite long. These were cut off. You know, this was assembled at the factory, and these were bent down about 90 degrees so they could be flow soldered. But the replacement's got these very long leads, and always the negative side's going to be the shorter one. But not only that, you can see a big minus sign on the capacitor, and that's going to tell you that's the negative side. And as I told you, I took a look before to make sure which way to orientate this, because on this particular, under here, you can't see it, you guys can't from the camera angle, but there is a minus sign that's printed here, that's silk screened here on the board. But again, don't always go by that. 99% of the time it's correct, but every now and then these will not be marked correctly. And always go by the way they were when you got them. You know, don't say, well, they must have put it in backwards at the factory. No, they didn't. Put it in the way it came out. And always, as I said, take a look. So we'll go ahead, and I'm pushing him up in there. And he actually sat in there really nice and tight. Sometimes they'll wiggle a little bit, right? And be a little bit loose. But in this guy's case, he's sitting really nice and tight up under the board. And so I can just go ahead and solder him. And again, I mentioned tools. You can use whatever type of soldering iron you want. There's a lot of good ones. I've got a Hakko soldering iron. Yeah, they're about, I don't think they run maybe $100 or so. And it's a great soldering iron, but you don't have to use one, you know, like this one. You can get one for 30, 40 bucks that'll work fine, but just don't go to the flea market. Get a $3 soldering iron if you're going to work on your precious vintage audio equipment. Just don't do it. So I'm going to go ahead and just solder these leads. And what I do too, I end up keeping all of my parts. I've just got a little bag over here. Little Ziploc. It says Technics SC 9600. And I'll put the old capacitors in there. And I keep those. Why? Nah. Who knows? But I do. I keep all the old capacitors from my restoration. So I'm going to go through now and replace the rest of the electrolytics. Let me go after this electrolytic down here at the bottom, and again I'm going to take a look, make sure of the orientation of the electrolytic capacitor, and the negative is over here left. And I can tell this is orientated differently. It's orientated, this one was orientated on the vertical, this one's like on the horizontal. This one again, and you always want to check that. Make sure that eyelet's loose, that pin's loose there. You know, you wiggle this, you can feel this being loose. And some of these eyelets will rip quite easily. And that's one thing that Hakko FR301 really helps you with. So it looks alright. And we do the same thing with cutting again, just like we did on the last one. Don't have to be too precise. You just don't want to cut down into that solder. And you don't want to leave these super long. So whatever you prefer. And again, you figure out where your cuts are. You get rid of that extra wire that you've cut off. I've got a few more to do here, so I'm going to go ahead and get those done. And now I'm going to replace a 470 microfarad 10 volt electrolytic capacitor. And I'll tell you that almost always I'll never replace the 10 volt capacitors that I do in my restorations with another 10. Usually I'll put a 25 in. Did this 10 volt one last all these years? Yes, it did. But these 25 volt replacements cost practically no more than the 10 volt. And so I'll go ahead and replace the 10 volt with a 25. And again, you may be able to see this, you may not. The capacitor coming out is an 85 degree centigrade rated capacitor, and the one going in is 105 centigrade. So you've got a little bit higher temperature rating, and that will hopefully make this capacitor run at its spec for longer. Okay, I've got the electrolytic capacitors changed out in the power supply, and now I'll mount it back into the chassis. Fortunately, I was able to get this assembly out. Didn't even have to undo a tie wrap. See that one? I see that one. There we go. Okay, we got it back up in there. And as you guys remember, all we had was 2 screws down here on the bottom. Let's see, my little. And what I do, you guys can do whatever you want to do. You start a project, you start removing these screws out, and then you're like wondering, well, where'd they go or what goes where? I just use a little dish. Okay, now with the power supply done, I've got the unit back sitting normally. Going to work on the driver assemblies. Just take the 2 screws out of the top. Let's take a look and see what we got here. I'm going to put this aside. You know, there's a left and a right driver. There's one under here too. But it looks like, which will be very nice if this is the case, it looks like it's a plug-in connector. And that would be great. Because then I could take this driver, remove it, and work on it easily. So that would be wonderful if that's the case. So I'm going to go ahead. Looks like there's 2 screws here. All right, we got that loose. Boy, it surely looks, unless there's something else holding us, it looks like I can unplug this. It really does. Let's see if that's the case. Well, oh, no, that looks all right. Man. Wow. You get over here. Doesn't look like anything else is holding it. Nah, it's gonna come. Holy smokes. Wow, look at that. I mean, whoever did the mechanical engineering on this unit, and there's something sticky on here too. I mean, I don't know what that is. Something. I don't know. There's something, as I said earlier, you know, there's something sticky down here in the chassis. I don't know if you can see it here from this angle or not, but there's something got spilt in here, I guess. I mean, I don't know, but boy, is that nice. How I wish every unit was like this. Holy smokes. It's right in my hand, you know. Now, this is good for what I'm doing, restoring, for troubleshooting. Oh my God, what a pain in the buttocks. You know, it would be the opposite. You'd have to go from the bottom here of this connector to do the troubleshooting, because good luck if this were mounted down in here and something was broke on here. And you had to try to troubleshoot. Imagine getting a meter, a scope, whatever, down in here. Good luck. Probably isn't going to happen, you know. I mean, certainly not easily. So you probably would have to turn the unit over and figure out what it is you're trying to look at this connector. Once again, that's fine coming in and out of this board, but if you've got something internal here wrong, it would be kind of I think a pain to work on. Great to change out electrolytic capacitors. A real pain though if you had to troubleshoot this. The good thing, and I'm assuming, although I better not, because just as I said that, I can see an L over here, meaning I'm guessing left, and over here you're going to see one that's probably got an R. I was going to say, well, this is nice. Maybe you can just go ahead and if you got a problem with one, you know, you can take this one, put it over on the right hand side, and vice versa. But maybe it does not work that way, and it probably doesn't. When you have an L on here, it tells you something. So probably they're not exactly the same. You know, the connectors are different or what have you. So that's good. Wow. I'll put I won't move him off the test bench. I'll still have plenty of room. What I'll do though, you know, when we worked on the bottom there on the power supply, I'm just going to lift him back up on his backside here. And I'll get in here and change out these electrolytics. And actually, while I'm at it, right, before I move the unit, that was so easy. You know what I'm going to do, right? I'm going to take the right one out too. Might as well work on them both at the same time. Sometimes I'll do things one thing at a time. In this case, though, this is so easy to get at. Geez, why wouldn't you? In this restoration, I'm going to show you a little bit more about how I pick components, how I do the restorations themselves. I don't show that all that often, and I thought this is a good opportunity on this amplifier to do that, how I pick components and how I just go about restoring a piece of equipment. So, I'm about ready to get started here on this first driver assembly. And I'm going to show you the capacitors I'm going to use with it next. I've got my capacitors laid out here, the replacement capacitors for the driver assemblies that we removed there from the top. Once again, so nice to have these in my hand like this. In this case, I'm going to use a couple film capacitors. I'm going to change out a couple of the different capacitors, electrolytic capacitors that were that are in the audio path. And there's a couple small electrolytics that I'm going to use film capacitors with. Also, I'm going to use some audio grade electrolytics for some of the little bit larger ones. Any of the capacitors that are in the signal path, I'm going to use audio grade capacitors for those. Okay, going to get started on the left driver assembly here. Just like before, going to use that Hacko FR301 desoldering tool that's going to make my life much simpler to get these capacitors out. And you can really start anywhere you want. Again, just make sure you take a look at the orientation of the electrolytic capacitor before you remove it, so you can make sure that you get your replacement back in. So I might as well start right here at the top. Why not? Now I can see here these leads are pretty long. They were put in. They're pretty big capacitors, and then they folded them down onto the board where they were flow soldered. So this may take a little bit more work to get these out. Sometimes you even need to flow a little bit of solder on there, and it makes it easier. But we'll give it a try. Just like this. Might have to work around it. You may not be able to see the how much lead there is here, but there's a good amount here. There's a good 1/4 to 3/8 of an inch. So I'm going to have to kind of work around that a little bit. Let's see. See, that does such a good job of sucking that solder out. I think we did all right on that one. Might need a little more work, but as I mentioned before, really the best way, you can get your thumb under like a board like this, and I'm going to work on this other lead and just start to suck the solder out and wiggle it at the same time. And that helps it come loose. And that one looks like it came pretty loose. This one here, I got a little chunk of solder, I can see it. Yeah, that's pretty good there too, I think. Maybe you guys can see those wiggling. And see, before I showed you that you need to straighten these to pull them out. Now look, these are quite long, if you can tell. And they look like they're pretty loose, which you can also do just as easily, right? And make your life a little bit easier. Instead of like me, a lot of times I bend them up. You can just go ahead and cut them, because they're not going to be used anymore, and cut these leads right off just about where they go down in through the eyelet, and then you don't have to bend those pins back and forth to get them straight and to get them out of the hole, right? So let's give him a pull and see if he comes out. Yeah, see, that one's loose, but this is, again, I told you about those eyelets. You gotta, if it doesn't want to come out, hit it again with your iron. Try to show you here. Just try to hit it right there with the iron a little bit. And yeah, there it came out. And give her a little bit of a pull, because the main thing you want to do is not damage those eyelets, right? So if it doesn't literally fall out for you, that's all you've got to do is just kind of hit. Just take your time, I guess, is the point. There's no hurry here, and certainly you're going to hold yourself up a lot longer if you rip out any of these little eyelets or something. So it's just better to take your time. So this is a 100 microfarad 63 volt capacitor that I'm going to be replacing, and I've got some 100s 100 microfarad 100 volt replacements. So again, bumping them up a little bit, 63 volt to 100 volt, and that just gives you a little bit more room there. Maybe down the road that'll be a difference. This capacitor, this 100-volt capacitor, will be under a lot less stress than the original was. So again, just got to make sure it's orientated right. Right, we've got, and then this guy shows a little minus sign here, and we knew before by looking at it, we knew the minus was down to the bottom of the board. So negative lead goes in there. And now see, before, I think I'm on the power supply board, these guys stayed up here tight. I don't know if you can see how loose that is. So if I push it, and I've got to turn the board over, right, to solder, it'll end up pulling from the board one way or another. And so the way to just get that to stay pretty much where you want to, you can spring these just a little bit. This one here and this one here. And that's going to hold them in place. I mean, easily. So you can see now this one's right up against the board, and now you can hit that with some solder. And I'll do the same thing they did. They, this is a pretty long land here, and they put a pretty good chunk of the lead down on here. So what I'll do is I'll just give this guy a little bit of a cut now. I'm going to give this guy a little cut right here. How's that? We don't need much. We don't even need to do this, frankly. And then we can push these guys down, make sure he's nice and solid there. And then you just take your pliers, push it flat. Take your pliers, push it flat. And as I said, you really don't even have to do this. But we'll put them back in like they had them. So there you've got a nice spot to solder, and you'll make sure those will stay nice and tight for a long time. So we get our solder, we get our soldering iron here, and then we can hit this guy first. And this guy here's got a pretty good amount of land area. So we had to put a little bit extra solder on there than you normally would with just a regular eyelet. And this guy here, we can push him down a little flatter. Just did that with my finger. And then we can hit this guy also. Same thing. And once you get the solder hot, you know, you don't have to really worry where you're at. It's going to just sort of flow. You know, it's like spilling a glass of water. Just, it's going to go. So that looks pretty darn good. And if you look over here on this side, it's nice and solid with the board. It's in there nice and straight, and that's what you want. Does it make it work better? No, it doesn't. But it just looks better, right? Looks a lot like the ones that that we replaced. So, and that's just the way of doing this board. It's the same thing as the power supply, right? We're going to go through and change out. We've got how many electrolytics on this one? I just changed this one. We've got him, so 1, 2, 3, 4, 5, 6, 7 on the board to do. And again, I won't show you each and every single one on here. I'll go ahead and get some more of these replaced and just continue on. Do I think I'm going to hear a difference with this film capacitor replacing this small electrolytic, or this audio grade capacitor replacing this other one? I don't know. As I've mentioned before, I've used about every brand you can think of in different situations, and I can't really tell you, as I've said before, that one's better than the other. Just use something of quality. I will use often a film capacitor to replace the electrolytic capacitors, because the small value ones, because it does seem that most folks feel that's a superior sounding capacitor or film capacitor compared to an electrolytic that's in that signal path. Okay, I've got both drivers finished up. Got those electrolytic capacitors, those 45-year-old electrolytic capacitors out of her. There's a very good chance these drivers won't have to come out for a long time to come. We don't know for sure. I mean, transistors do go bad, diodes do go bad, but it's those electrolytic capacitors that go bad most often. And even if they're not causing you an issue, at least you don't think they are, they degrade over time. If you've got a 45-year-old piece of equipment like this, and you still have old electrolytic capacitors in it, the odds are that it doesn't sound as good as it could. It doesn't mean you don't like it, doesn't mean you don't enjoy it, but it could probably function better with the new electrolytic capacitors, because over time they all fail. Doesn't matter the brand. After this many years, they've all deteriorated to the point of many of them will be out of spec. And as I said in previous videos, most of the time, occasionally they do, but most of the time they don't blow up on you. But at some point they'll fail, and unfortunately when they fail, a lot of times they'll take out other components around them. And so these capacitors are available. They're readily available still today. Some of the other electronics may not be. You may be able to get an equivalent for a transistor, but you can't get that original one again many times. Resistors you can get, that's not a problem. But that's one of the big issues. It's not like this capacitor goes and then that's it. A lot of times it'll end up putting voltages at certain points that shouldn't be there. And so if you've got a transistor that's only rated at 50 volts and suddenly it sees 100, it's going to fry that and maybe fry a couple other things along with it, or fry a whole bunch of things. And really one of the worst things that would happen, especially with these driver assemblies failing, is they take out your output transistors. And that would be, that's kind of that's a bad thing. So a lot of times it's just better to get in there, get this old stuff out of there, and it's going to give you a better sound, but maybe even more importantly, it's going to give you reliability, and your old vintage equipment will work for many decades to come. So now I'm going to take these and I'm going to mount them back in the chassis, and like I always do, I'll mount them back in, I'll power it up and see if everything's working all right before I move on. Now I'm going to mount those driver assemblies back into the SC9600, and we'll give it a try. So as you recall, these had left and right sides, and the connectors are different sizes, so we can tell this guy's got to go in this way, right? Now we'll get the right side in there. Same thing, just make sure you line the connectors up. No big deal, but just make sure they're lined up, and then just kind of give it even pressure on both sides the best you can. One side may start before the other, but it's alright. There we go. Okay, after testing out the amp, making sure that it'd power up again after doing the work there to the power supply and the two driver units, I'm going to reseat the power transistors with some new thermal compound. I'm going to go ahead and do that, and then this amp will be running for probably another 45 years. It's just another way to keep them a little bit cooler and hopefully keep them running for a few more decades. So now I've got the unit back down flat. In this unit, which you don't see very often, there are little plastic covers over the power transistors. I've got a little portable light here for me to look down in. They look like they're just pressed in there to me, and see if I can just pop it out of there. Now again, what are we dealing with? 45-year-old plastic cover. Any of you guys that work around vehicles with old plastic or whatever, you know, every time you touch it, look out, right? So I got to be very careful with this, but I've got to take this cover off. If I want to reseat this transistor, I've got to take this cover off. So what I'm going to do is press here a little bit. See if we can get it to move. So here we go. And I'm going to take it real easy with it. Okay. It's moving. You may not be able to see that, but it is starting to move. See if I can get behind it at all. Come here. Oh, there we go. It just popped right there. Now again, what are we dealing with? Old plastic. It's tight. I probably should try to get up on the other side of it here a little bit. This worries me. I want to get this evened up. You know what I mean? Yeah, like that. I don't know if you could see that or not. That's much more easy. Instead of pulling this plastic in one big swoop. I know this is taking a while, but this is what you got to do with some of this stuff, right? I don't want to break these. Can I order these? No. I want to get in there, so... And what do you know? I think we're pretty good. I'm not going to say we got it yet. I'm going back down here for a second. There we go. And, well, there we go. We got it. We didn't break it, right? But you got to be patient. That's one thing. You just got to be patient. This is a pretty thin piece of plastic. And it's been around a power transistor for 45 years. So you know it's sustained some heat. And you just got to be extremely careful. And now I can see how it's attached, actually. I can see how this one's attached. See these little tabs? You may not be able to, I understand, on the camera, but there's these little tabs. So I'll put that over there. Now with the covers off, I'm going to remove the transistors. The power transistors in most units, and I can tell this is a typical one, has a socket that's held in by these screws outside of where you see the power transistor. And then here holding the transistor are the screws into the socket. So these two screws to the outside are the socket. You don't want to remove those, but you do want to remove these two here. Some amplifiers are a little bit different. The whole socket comes loose. But in this case, this is typical. Take these two screws out, and then this transistor will come right out. So I'm going to go ahead and do that. Came loose, but I usually loosen one, then loosen the other. They're loose, and the transistor now will pull right out. Many times, it's going to be real tight for my fingers to get in here with one hand. Most of the time, they're not quite this deep, and you can just squeeze them and pull them. This one, I'm going to kind of have to do the two-hand system, or the two-finger system here, and kind of wiggle it, I think, to get it out. And I'll probably block everything here, but the idea is, however you can get a hold of this guy, maybe I can get him with one hand. Let me try it. Yeah, I think he's coming. It's going to be a little bit hard to get out that way, I think. Now I got the two-fingered system, but you don't have to worry about hurting anything. You're not really, you know, these power transistors, you think this is the transistor. Well, it's just the case of the transistor, right? It's not like you're going to squeeze it and hurt it. The transistor's inside this case. So he comes right out, easy enough. These power transistors are keyed. They're slightly off center with each other. So it's impossible to put this in wrong in this socket. You could put it wrong in one of these other sockets. In other words, get two transistors mixed up, but you really can't get it mixed up here. But it's always a good idea to take pictures, make sure you got it orientated right. But came right on out of there. No issues at all. And down in here, you may be able to see that insulator. I don't know if you can or not. But we're going to take him out. I'll probably get he might come loose, but pry him with a little small screwdriver and he should come out of there. Because once you get this started, it'll peel right off. Or maybe even, do I have a pick out here? Pick works good sometimes. Okay, there she comes. What you want to do is to get in here, and I'll rub it in there a little bit, and really there's not a whole lot to clean up because there's not much thermal compound. And this alcohol will evaporate here in just a few seconds, so we don't have to worry about waiting anything to dry or anything. It'll go away shortly by the time I get the thermal compound out and the new insulators. And that reminds me, we're going to put new insulators in. We're not going to put this 2-3 cent insulator back in, right? We took it out, so we've got insulators that brand new ones that we'll use. These again available at DigiKey, Mauser.com. Another part that you can still get, no issues. You know, you can get these, but we're going to put thermal compound on our insulator and transistor. And that reminds me too, we don't just clean the heat sink. Now we're going to use a new insulator, so we're just going to toss this guy away. But the transistor itself, we want to clean also. I'm going to go ahead and put the new thermal compound in the new insulator and reinstall the original power transistor back in here, and hopefully she'll be good to go for another 40-45 years. This thermal compound is some messy stuff. No getting around it. It cleans up readily with alcohol. It's no big deal. You're going to make a little bit of a mess with it. So just if you're going to do this, get some quality thermal joint compound like this one. Wakefield makes great stuff. This jar, this big, would last you for the rest of your life if it didn't expire. You know, it does have an expiration date. They're good for about 5 years or so. Really, the way to apply this, there's no easy, non-messy way. I just use my finger. And you don't need very much. You really don't. Just spread it the best you can. There's no need for super accuracy or anything like that. It's just messy stuff, that's all. So you want some on the transistor side of this insulator, and you're going to want some on the insulator side that's going to hit the heat sink. So we put a little bit on the transistor side, and what you can do, like right now, you just give it a little mask job, and this will help it just kind of flatten out in there and cover 98% of what you're trying to cover. And you just want a very thin amount, and you can kind of move this a little bit, and this has gotten it, you know, spread out pretty evenly between the new insulator and the transistor. And so again, the easiest thing to do is put a little bit, not much, again, a little bit of this goes a long way. Just start spreading it out on the insulator side. Now you can rub this down on the heat sink, but then it makes a little bit more of a mess, right? And don't worry if you get some of this stuff on the transistor. I'm holding the transistor, and you're going to get some of that on the transistor. Don't worry about on the transistor case itself. Don't worry about getting it on the transistor case or anything. And you just spread that out as good as you can, because we'll clean that up when we put it back in. But now you take a look and you orientate this guy just like he came out. So if we took a look, next guy to him, but as I said, you can't make a mistake with this. If you put this in and it won't plug in, then you know you have it 180 degrees out. And as I said, this is a little bit messy. And this guy too, one thing about this guy, he's deep. He's going to be hard for me to get my fingers in there to get this in neatly. I'm going to probably have to two-hand it here. Let's see. We don't mind if you pop up like that a little bit. Try to keep my fingers off the goods here a little bit. There. And I just felt him go in. And then you can feel him in the socket. Just give him a push. And then we can give him a little bit of a twist. A little bit of a make sure he's seated good kind of a feeling here. And we're not worried. And you can kind of see here, we've gotten some of this thermal compound on the transistor. We can clean that up. I'll clean that up in a minute. And so that's good to go. And all we got to do, we'll put our screws back in. And these you want snug, but you don't want to crank down on it. So there he is. There's the new old power transistor in there. And he'll be good to go here for, you know, decades to come. And so now it's just a matter of going down the line and doing them all. It really doesn't take very long. It's a little bit, as I said, a little bit messy, but no big deal. And so I'll go ahead and get the rest of them done. As I said, you know, it takes you a little while. It's something that'll take me an hour or so to knock out, right? You cleaned it up pretty good. And again, you can see that the thermal compound is there, but not overly there. You know, it's not all spread out all over the place. So once again, it gives these transistors an easy life for the next 40, 50 years that this amp should be running. All right, I've got the transistors all reseated, and now it's time to put those, remember these little covers that we had to take off. So I think they'll go right in if I kind of even them up here and just kind of give them a push in evenly. Let's see what happens. Probably will go. Feels pretty good. So, well, that sounded good. Heard it click in, so that's good. There's one. And I'll do another. Kind of try to do it the same way. Kind of push it in evenly here. Whoops, got that a little too low. That's better. And yeah, so these guys will just click right in. So I'm going to go down the line and put those back in. Take one more look here underneath. Everything looks good. We've powered the unit back up, and we made sure it powered up and both channels were working, and everything still seems to be good with it. So I'm going to go ahead and put the bottom cover back on now. You know, you guys probably don't need explanations how to put covers on with screws, but you know, usually you start on one corner like I have up here, and then you get another one started, you know, down in the other corner. Now I'm about ready to put the faceplate back on. One thing that I use that I got not that long ago, maybe a couple years ago, is this little rechargeable air duster. I don't know. Can you see the box? Maybe you can. But it's this guy here. And I used to use compressed air and that kind of thing to just do a little bit here on the face plates. There's a little bit of dust on this inside part. This guy here does a pretty good job. You can probably hear it. It's got a good amount of air that comes out of it, and it's got a couple of attachments. A lot of times there's this little fine brush that's on the end of it, and you can kind of just move that along here a little bit. And get those few pieces of dust that may be there. And the same thing here. I got the face plate in my lap, and I'll do that a little bit too. I'm not worried about the outside part, just this inside. You know, you've got the meters, and then you've got this inside area here that you're concerned with. So I'm going to go ahead and put that on. I've got the unit unplugged now, and to put these face plates on, I mean, I may be telling you guys something you already know, but you end up just getting all of these switches even, whatever that takes. This isn't going to go on if this is down. So the power switch, you have to turn it on to be able to get this faceplate back on. And felt pretty good. Yeah, that felt pretty good. I think it's going to be on. And on this particular unit, I'm not going to clean up this faceplate a lot. I got the worst dirt off it. Once I get the knobs back on it, remember I put those in this little dish here in the beginning. So I'm going to go ahead and get the knobs back on here and get the faceplate back on. But I'm not going to try to clean this much. Get the worst of it off, because it is really scraped up. Somebody has scraped their name into it. You know, I don't want to take away, I know this is going to sound silly, the charm of this. I don't want it to look brand new. I don't want it to look perfect. First of all, it couldn't even if I wanted it to. But I want it to look like it looks. There's no way that you could replicate this if you tried to make it look like this, right? It's beat up in the front. It's beat up in the back. It's beat up internally. It's beat up. But the thing that was very important to me is what? Get those 2 meter lamps working. Get that power lamp working. I wanted those working. None of the 3 worked initially. So I want that to work, but I frankly could care less that this faceplate's all beat up. I want the unit to have its lights. I want the unit to operate properly. And there's no reason this unit won't go as long as one that's in pristine condition. It's all cosmetic what's wrong with it. And frankly, I think it's kind of cool looking. I know y'all are probably thinking, yeah, real cool. I'll beat the heck here. But I really like this amplifier. I like the way it looks. I'm sorry, but I really do like the way it looks. So I'm going to go ahead and get these knobs back on this faceplate. I'm bringing out the Technics SC9600 here. Put it up here on the hose box for a minute, if the hose box will hold it. I'm going to take a brush, an old paintbrush, and just kind of clean up these heat sinks a little bit. We might as well just start with her sitting just like this for now. And I'm going to get go get an old paintbrush and just brush some of this dirt off it. I'm not going to clean it up. I'm going to keep it looking pretty much like it is. But I am going to get that top layer of crud off it. So let me go grab an old paintbrush and I'll show you what I do just to clean that up a little bit. As I said, I'm not going to clean this amplifier all up. I'm just going to get the worst of it. And paintbrush is a great way of doing that. I might as well start here on this heat sink and just brush away a decent amount of this stuff. We'll just get the top layer really, but it's a good way to do what I'm trying to do with this unit. Is I'm trying to not make it look new because you just can't, right? You guys see a lot of times I'll really try to make the units look as good as I can, brand new, but this one, it just doesn't fit it. It just doesn't. You know, when I first saw it, I thought if I get it going, get it running, there's no way I'm going to try to make something like this look new because it just can't. The knobs are scraped up. You can see the faceplate is on real rough shape. I haven't shown the back of the unit. I'm going to turn this around and show you the back of the unit. It's in rough shape. I showed you down inside it. It's very dirty and has some surface rust, so I'm going to just clean it up here some. And I bring it out here, right, instead of doing it in the house and getting all this crud all over the place. Use my little blower in there for something like the face plate or some little area. But like this, just bring it out here and really get a good amount of it. Top layer of it anyway. Be a little careful in here. Don't get too crazy. Like I said, I'm not really trying to make it look perfect. I want it to look like it looks. As you guys know, I enjoy the history of this stuff. And this amp's got a history. I don't know what it is exactly. I got this from my high-end dealer here locally. This wasn't like a trade-in on some of his AR equipment or his focals or, you know, the different high-end equipment he has, but people will bring stuff in off the street like this. You know, they clean out their uncle's you know, estate or whatever, and they find this stuff and they take it to somebody like him, because that's about the only stereo shop left in town, right? You're not going to take this out to Best Buy and see what they'll give you for it. It's right up my alley though, right? That's good. I mean, I got the top layer off. At least this stuff won't come off easily in the house. I mean, there's plenty of stuff left, but whatever a paintbrush will take, it's pretty much taken it. So I think that's pretty good. Why not give the faceplate a little scrub too here, a little bit. All right, here we go. I think about ready to go back in the house, and I can continue on here. We're getting pretty close to bench testing. As you know, we went through and got all the electrolytic capacitors out and replaced. Power supply and then the 2 driver assemblies, reseated all the power transistors and put in new thermal compounds. So I think she's about ready to go up on the test bench, and we'll see what she can do. You always want to have the service manual available before you work on the unit, or in this case I'm going to check the DC offset and also the idle current in the amplifier. And the service manual provides that information. So I have up on the screen right now the service manual for the SC9600, the Technics. This manual is available at hi-fi-engine.com. It's a free download. You just have to create an account, and you can download all the owner's manuals, service manuals, brochures, whatever they've got on your particular unit, not just on this unit like this Technics XC9600. So you go ahead and download that, and then within this manual you've got the schematics, you've got all the information that you need, the components that are in it. And what we need is the alignment instructions, which is up on the screen right now. And this tells you where the test points are. You may not be able to see this, but you're using the test points, which are right up here on these driver assemblies, right up here at the top. If you can, use 2 meters. Because this makes it easier. You can hook up 2 sets of leads and monitor both channels at the same time. If you don't have 2 meters, that's okay. But you just have to be careful about hooking your leads up if you're going to move them from your one channel to the next. So 2 meters are better, 1 meter's fine. It'll work fine for you. You just, in this configuration with 2 meters, we can hook them both up and look at them at the same time, which is just convenient, if nothing else. So what I've done right now, I've just hooked up both sets of meters, the negative and the positive leads, to the left and the right channel. and with a pair of alligator clips, and I've got those hooked to my meters. And now I'm going to turn on the 9600, and I'm going to see what we have for DC offset on both channels. And if it needs to be adjusted, we'll be able to do that. So what I'm going to do first is power up the 9600. And so we have it powered up. It tells us that our output level controls, this is the service manual. I'm looking up here at the screen at the service manual. And what it tells us is to put the output level controls to maximum. It tells us to set the speaker switch to on. The output impedance switch to normal. So again, this is all information that's in your service manual, and you wouldn't know how to do this. Even somebody, because every amplifier is a little bit different. Yes, they're very similar, and people who work on this stuff all the time maybe don't have to follow this. But I do, and most people do, so that you know you're setting up this particular piece of equipment correctly. So I've turned on the speaker switch. I've got the output impedance in normal, and I've got the output levels at max. And now, let me try to swing this back around here to show you the meters. See if this will work for us. I think so. So what we've got is really less than a millivolt. This is I have the left channel hooked to this meter. I have the right channel hooked to this meter. So we're just a hair over a millivolt DC offset in the left channel. Am I touching that? No, I'm not. That's as, you know, it's just going to be as good as it gets. You start going in there, turning stuff, and it just isn't worth it for, 1.2 or 3 millivolts. And the other channel is about 3.8 millivolts, 3.7, 3.8. Whether that's coming through on the video, I'm not sure. But that is just outstanding. I'm not touching it, either one of them. I mean, that's as good as it gets. You could just screw around all day long and never get them that close. Because ideally what you want is 0. You want no DC voltage at your speaker outputs. But when you have between 1.5 and 3 or 4 millivolts, that's beyond excellent. That's the DC offset. And now we're going to go for the idle current next. So now I have the leads, I've moved them from the speaker output terminals to the test points on each driver card. And I'm reading up here on the screen, and it tells me to connect the meter, the positive lead to TP2, and that's marked on the board, and the negative terminal to TP3, which is also marked on the board. And so on both channels we have that, and again did the same thing down here. These meters, one is on the left channel, and this one over here is on the right channel. So again, I have the amplifier off right now, and I'm going to turn it on, and let's see what the meter sees. So here we go. So it's on, and when you do idle current, this tells me to let the amplifier warm up for 5 minutes. That, for most amplifiers, that wouldn't be long enough. Most of us, we turn on our amplifiers and we leave them on for, a length of time. an hour, 2 hours, whatever it happens to be. And I've found that probably 5 minutes isn't long enough. I'm in no hurry, I guess. Maybe if you're doing this, again, for a living, you do exactly what they say. But I'm going to give it more than 5 minutes. I'm going to give it, at least 15 minutes and just sit here. And right now, I don't know if you can see it or not, I'm supposed to have 5 millivolts at those test points. You can see both channels are right around 3, just a hair under. Now I noticed when I first powered it up, it was about 2.5. So they're rising, right? They're starting to move. The right channel's now at 3.1, the left channel's about 2.9, and so now we've got to give it some time. And let's see if it gets up to about that 5 millivolt level. It doesn't look like maybe it will, but it may surprise us, because sometimes these things can really change. As this amplifier's warming up, this current, this idle current's going to change. And you can see, just as I'm talking here to you in a few seconds, 3.3, 3.0. Maybe it's going to surprise us, and it's going to end up around 5 millivolts. But I'm going to give it about 15 minutes, and then I'm going to come back to it and just see where we're at and see if we need to do any adjusting or not. After 15 minutes, these guys are right around 5 millivolts, as they should be. The left channel's about 4.75, the right channel's about 5.2. Again, am I going to move anything? Am I going to adjust this to try to get it exactly at 5? Because you can really go down a rabbit's hole with trying to adjust the idle current. Because as soon as I move the pot that controls this, this is going to run one way or the other, up or down. And you can go on forever trying to get this exact. So that's what I'm going to do. I'm going to leave it as is. I'm going to go ahead and do the bench testing on it. And what a surprise, huh? Well, not really. This poor amplifier is in horrible cosmetic shape. But it's performing like it was brand new out of the box. It really is. It's just a testament to how good this equipment is. So after 45 years of, as you guys can tell with this one, a lot of abuse, I did not have to make an adjustment. It's right where it was when it left Japan back in the middle 70s. Pretty amazing. I mean, I think, and this is one reason I love this equipment, is this thing went through as much heck as anything could, and it's operating as good as a new one. It'll never look pretty, but it's going to, I think, really sound good. But first of all, before I listen to it, I'm going to put it up on the test bench. I'm going to verify the power, its power specifications, its distortion specifications, and we're going to see what this SC9600 can do. So I've got the power off. Again, power off, right, before you do what I'm doing here. Even though these are insulated, you can still make a mistake, and it would be a horrible thing to happen. So any of you guys that are thinking about doing this, just be careful, right? You can tell it's not all that darn hard, is it? I mean, really, is it that hard? You got the service manual, it tells you where to hook stuff up, and it tells you what you should have at those points. I mean, what more can you say? And then, I mean, you got to remember that there used to be, no more, but there used to be a lot of people that worked on this equipment. Every town had a service center. The big shops had their own service department. And remember that the manufacturers wanted you to take care of yourself. This was long before the internet. If they didn't have a service manual, if they didn't explain to you where to put a probe and what you should expect at those points, they'd be getting phone calls all day long in New York, New Jersey, California, wherever. They all would, right? Technics, Pioneer, Marantz. Oh no, somebody doesn't know how to check DC offset. Somebody doesn't know how to check the idle current. Somebody doesn't know how to do something. So they gave you the service manual to hopefully, for the most part, take care of yourself. And the only time they got bothered was when they had a situation that was unusual. So keep that in mind, that a lot of people worked on this stuff. I'm not going to say that there aren't times when things are difficult to fix, but also realize that with some effort, that many people can take care of their own issues with their vintage audio equipment. All right, we're going to do a little bench testing on the Technics SE9600 power amplifier. I've got my Sound Technology audio analyzer, 3200A, up on the test bench. A couple 8 ohm, 300 watt load resistors, signal generator, and we'll see what this 9600 can do. So we're going to see how balanced the channels are. We're going to see how much power the amplifier can put out, and we're going to check out how much distortion the amplifier also is producing. I'm going to run the power up a little bit to let the amplifier warm up for a little while, give it 10 or 15 minutes to stabilize, and then I'm going to run it a little bit harder, and we're going to look at the distortion numbers. So for right now, I'm going to run up the signal generator a little bit here on each channel. As I said, right now I just have a 1000 hertz sine wave at 100 millivolts. I'm going to take it maybe to 300 here for a minute. Let's see what we get up to. We get up to about 3.72 watts. I'm going to change the other one to that. 300. Let's see what we get. 3.72. So that is excellent. The two channels are tracking very, very close together, is what that shows you. Looks like the power meters are moving a little bit, but we're on ×1. So let's just here for a moment go to a little more sensitive level. And that just about pegged them, the most sensitive level there. So just to see them work, and they look darn close. We'll put it back down here on ×1, so when we start running it up, we don't peg the meters by mistake. I've been letting it set here a few minutes. We're running about 11 watts, 11.1 on the left channel and about 10.9 on the right channel. And as time's gone on, I can feel the warmth of the load resistors, and the heat sinks are warm. I mean, you know, they're not that ice cold like when you turn them on. You know, they're by no means hot at all, but they're warm. Well, first of all, let me tell you, this amplifier into 8 ohms puts out 110 watts a channel, or it did when it was new, at 0.08% distortion. So just under 0.1, 0.08. It'll put out its rated 110 watts a channel into 8 ohms. Let's just take a look and see where we're at. So all we've got to do here on the audio analyzer, right now we're just looking at it flat, just monitoring the two channels. And I'll go ahead and hit the total harmonic distortion button. And it's reading right now channel A, which is the left channel. And it's about 0.0368. So well under 0.08, certainly at this wattage. And I'm just going to go over to the B channel real quick, and it's 0.0284, so just under 0.03. So, you know, 0.03, 0.035, you know, somewhere in there for the two channels. So those are both excellent. So we're 700 millivolts going in. I mean, 21.8, 21.6. Those two channels are really tracking close. And just looking here, the meters show the same thing. Now, there's a test that we can do that will get us to calibrate these meters. But I will say, just looking at them with my eye, I don't know if the camera can really see that, they're dead on. You know, they're just about dead on even with each other. So let's just go ahead and hit the distortion button again. We're running, you know, 21.8, 21.6 watts continuous. That's, you know, that's doing a little bit there. That's gonna make some sound anyway, and at least hooked to most speakers. So 0.0261 on the left and 0.013 on the right. What can you say? Remember, 0.08 is its rating. And this is the thing I love about so many pieces of vintage equipment that I have. They are just rated so conservatively. This is way under 0.08. Now you're going to hear 0.08 compared to 0.02. Maybe you're not listening to it, but it was the way things were done back then. Things were over-engineered, you know, things were under-promised, you know, and then almost always they'll beat their specifications. And then you got to remember, this is 45 years later. This isn't brand new, you know. And then you guys saw the video. This poor amp went through quite a lot, and here it is, still performing like it was a new amplifier coming out of the box in 1975. I just find that just amazing about the old stuff. You know, it's just built so well. So we're just letting it sit here. These guys are warmer, absolutely. I mean, nothing to worry about. You know, it's a Class AB amp. It's gonna be a little bit warm, but you know, more or less what I would expect. So, and that's good too. As you recall, that I reseated those power transistors with some new thermal compound, and that's their job, right? Get that heat onto these guys and get it away from the transistors, right? So, yeah, he's warm. She's warm, but nothing, you know, you can see me. I don't know if you can see it, actually. I keep my hand right on it. No issues at all. Let's go ahead and run her up another notch or two. Let's see what happens here. Let's run her up a couple notches. What do we get to? Get the other channel there. Now we're about 35. Let me go back. And actually, I'm here still on the B channel, which is the right channel, 35 watts. And look at where we're at. 0.01% distortion, under 0.02. Again, 0.08 is its spec. Let me go over to the A channel. 0.0187. I mean, incredible. The wattage, 35.4. The wattage, 35.1. So very, very even. If you get that close with channels tracking, it's as good as it gets. Again, it's as good as it gets. You can't really ask for much more than that. So it's now we are running it right now. You know, I'll go through different frequencies, but I'm not going to go through the whole testing with you. I just want to show you though that we do all this work. Right? I mean, I go through and I change out the electrolytic capacitors, and I make sure then the unit's running correctly. As you saw earlier in the video, went in there, made sure DC offset was correct, made sure the idle current was correct. If the idle current's correct, that's where these channels will track together. If that's way off one way or another, you either won't get the power output out of them, or if the channels are mismatched, one channel will be way off from the other. And as you can see, they're very, very close together. So let's go flat here for a second. You know, 35.9 and 35.7. I mean, you're not going to hear that. And if you were running your amplifier at that type of power level, continuous, you're going to be having peaks that are beyond the capability of this amplifier. And here we are 45 years later, just letting her sit there and cook, right? Let's see what she feels like. Oh yeah. She's warm. She's warm, but not abnormally warm, you know, like she should be. The two sides feel the same. The two sides are testing the same. You know, both, this is the left side. I don't know if you can see my hand here. I'm just resting it over here on the heat sink, and then I come over here to the right side. And yeah, they both got some warmth to them. But like they should. I could leave this here and go to bed. And I'm 100% confident I could come back and she'd still be sitting here like this. You know, this is the kind of equipment that was built back in the 70s. You know, I mean, it's just amazing stuff to me, it just is. And this piece of equipment that was abused for so many years, I'm going to be really excited to listen to it. Because, I mean, on the test bench, it has just, it's performing wonderfully. And, boy, if it sounds anything like it performs, I'm going to really enjoy it. Well, we're just got it hammered. We just got it locked right here. It can't move, right? About 62 watts a channel. And you can see the distortion just stays right where it is, you know, 0.034, 0.042. I mean, this thing is solid as a rock. Yow! These are getting warm. Now, and again, these are 300 watt load resistors. And, you know, they're warm enough to get my hand off it. These things are still doing all right. I mean, don't get me wrong now. They're warm. They're warm, but if my amp was running like this, I wouldn't worry about it. And I don't think the transistors are worrying about it. They're just, you know, they're just cruising along there, just like this amp is. I mean, it's impressive. It really is. You know, and a lot of times this older equipment, I just let it run at a reasonable rate, right? You know, it's kind of like, I think everybody, well, run it up to 110, and I'm sure it will do it. Or run it up to what it'll ever clip at, and I have done that in the past. But I think the thing's 45 years old. It's amazing. It's sitting right here doing half of its power. It'll never run this hard in a music system, right? The only reason it's running this hard is because it's getting a continual single sine wave into it. And it's having to run a lot harder than it'll ever run in my system. I mean, and I do like loud music, and I may even get up in the peaks like this one's running right now. I'll listen to it loud sometimes, but it's going to be that, you know, these peaks up and down, transits up and down, not just locked in here like it is. I'm going to go ahead and do a little more testing. No need to keep, you know, keep talking about it, keep showing it, but I'm just so impressed with it that I'm keeping the camera running. It's just how it is. You know, amazing. I just sit back here and I just I marvel at this thing, that after all these years and all the abuse it went through, it can perform so well. I mean, it's really incredible. So I am going to shut her down finally. You guys are probably thinking, good, you know, go ahead. With the restoration work done on this SC9600 and the restoration being verified up on the test bench, I'm very confident that when I hook this amplifier up into my main system, it's going to sound as good as it did when it came out of the box, or as close as it possibly could when it was manufactured in 1975. This is a prime example of how a piece of this vintage audio equipment can be beat up, stuck in a barn, and still be able to operate and operate reliably for decades to come. I truly believe this. I think this amplifier will see its 100th birthday. Many of you know that follow my videos, I'm very passionate about getting those old electrolytic capacitors out because they are the #1 failure in vintage audio equipment. And once you get those removed, you've got 90% of your problems out of it. And there's a good chance it'll run for decades longer without those old electrolytic capacitors in it. And this 9600 was a great example of why you should restore your piece of equipment and not wait until it fails. As you saw along the way, this particular amplifier was quite easy to restore. all those assemblies were easy to either remove or to get in a position for me to change out those electrolytic capacitors. If this amplifier had a problem and I had to troubleshoot one of those driver assemblies, it would have been difficult to troubleshoot those driver assemblies the way that they're mounted in this amplifier. So to me, it's a no-brainer. Just for a few dollars, there's only a few bucks in this amplifier. I did not have the filter capacitors, let me mention that. I'm going to change those. I had to order those. The rest of the capacitors were all quite inexpensive, and I've probably only got $20, $25 in this whole restoration. For you guys out there, the same way, it is so much easier to restore this equipment than repair it, because now you're going to have to really know what you're doing. And even if you know what you're doing, this particular amplifier, if you had to work on either one of those driver assemblies, it'd be interesting. It'd be very slow going and also dangerous, more for the equipment probably than you, but it would be very difficult to get a probe down inside those driver assemblies and to really troubleshoot this in any type of an efficient manner. As I mentioned before, very easy though to get in there and restore it. Removed them, put them right in front of me, piece of cake. Something else could happen, but the odds are that this amplifier is not going to have to be apart for decades. You know, I don't know, 10 years, 20? I mean, we don't know for sure, but there's a very good chance I won't have to ever get back into this amplifier. Somebody else will down the road in 30 years or 40, but I won't have to ever get into it again. But it's just silly if you're capable. Now, I get it. If you're not capable, if you don't think that you can get this apart and get it back together all right. And the biggest trick in this one really was if you can solder and unsolder. Because you saw it. I showed you from all different angles. Was it really that difficult? I think most of you are looking at it saying, I can take out 2 Phillip head screws and just move that board down 90 degrees like I did with the power supply. Or like when I did the driver cards, you looked at the top, I took out a couple screws again. I pulled it out of a connector. Was that difficult? No, it's almost more difficult to make a pot of coffee in the morning, honestly, right? The big trick and the big key and where things can go wrong is if you're not capable of soldering, and usually that's about having the tools. And you saw that I have that Hacko desoldering tool. It's a wonderful tool and it makes me look smart, because it's difficult sometimes to get these components out of these circuit boards without damaging them, because you got to remember they're older. So I get it. I get that it's not, you know, just something you can do, but you can see that the actual process for restoring this amplifier was pretty easy. Really could get it apart pretty easy and back together pretty easy. The whole trick is the soldering part, being able to solder and unsolder those parts. And I'm not trying to talk you into ruining your equipment. If you don't think you can do it, you can't do it. But I tried to show you, this was quite a long video, and I just tried to show you every detail I could about a project. Once again, it's not that hard if you take your time and do a little planning. This equipment's not going to go down easily. It'll keep running for you. At some point, you've got to do some basic maintenance on this stuff. And really, the main thing is those electrolytic capacitors. The main thing you need to do is get those 40 and 50 and 60-year-old electrolytic capacitors out of your piece of equipment, and you're probably good to go. So now I've got the 9600 hooked up here in my test room. A lot of times I'll hook up a piece of equipment once I get done with it right in the same room that I worked on the equipment. And this way I can let it sit here. I can have it on for several hours. I can listen to it a little bit more than I could up on the test bench. And so now I've got a decent pair of speakers hooked up to it instead of the cheap ones from the test bench. I've got a CD player that I've run directly into the RCA inputs, and I'll just control it by the output controls here on the amp. I'll control the volume down there. So I'm about ready to turn it on. I've got both speakers hooked up. I've got the CD player hooked in. And so the next thing is to turn it on. So I'm going to go ahead and do that. And it looks like it powered up. Looks good. We got the power LED and we've got the meters lit up, so it looks good. This 9600 sounds great. It is very clean, clear, open, crisp. I don't know really how else to describe it other than whatever you put into it is what comes out of it. And what more can you ask from an amplifier? It's got a ton of power, seems effortless. Most people are not going to need more power than this amplifier can produce. Well, there's my Technics 9600 power amplifier. It was worth every dollar and every hour I worked on it. I'm so glad I did. I'm so glad it's up and running. I'm so glad it's going to continue on for decades more. It is a wonderful amplifier. It's the only Technics amplifier that I have in my collection. And after working on this amplifier and after listening to it, I think I'm going to get some more of them if I ever get the opportunity. I hope you enjoyed the video. I know it was a long one. There was a lot in here. And any of you guys that are still hanging after your 6th beer or 6th cup of coffee, I really do appreciate you watching it. And if you enjoyed it, please give me a thumbs up down below. And for you non-subscribers, if you enjoyed this video and you'd like to see more of them, please subscribe. And as always, thank you so much to my present subscribers. Y'all have a good day.